Hi everyone, and welcome to this presentation of the ETSI NFV proof of concept named Orchestrated Assurance enabled by NFV. This is the video version of the live demo shown at the SDN OpenFlow World Congress in Dusseldorf, Germany. This PoC is carried out by Orange, Cisco, Intel, Netrounds and Telco Systems. Presenters today are me, Mats Nordlund from Netrounds, as well as Dr. Stefan Wallin from Cisco. So let's first have a quick look at how the presentation is structured. We'll start with the pains, problems, and the goal we're targeting, and then we'll describe the approach taken in this PoC before we outline the use case and the topology. The first three sections will take about 10 minutes, and then it's time for the live demo. But before we get started with the first section, let's have a quick look at the observation made by the PoC team that actually triggered this whole PoC project. In the past, both fulfillment and assurance workflow have been predominantly manual, error-prone and requiring extensive field visits. Configuration has often been done through CLIs, homegrown scripts and the likes, and testing and monitoring have been performed using application-specific hardware. So today, service providers around the world are embracing orchestrated fulfillment as a means to speed up service configuration. However, activation testing and ongoing monitoring as well as troubleshooting is still extremely manual and handled separately from the configuration. So the full benefit of orchestration cannot really be gained. So the PoC team got a really bright idea. What if we could do orchestrated assurance using software-based test agents in combination with this orchestrated fulfillment? This means that the orchestrator both configures the network and instantiates an accompanying test and monitoring solution to close the loop and bridge the gap between these two workflows. We believe that orchestrated assurance will really eliminate a lot of today's frustration for network operation and delivery teams. So let's have a look at the pains that we are addressing. The first pain is that network operation teams often have limited remote insight into true end-user experience. And in order to get this insight, engineers have to make field visits to measure from the customer's point of view, which of course is very costly. Alternatively, they could use hardware probes that they are locating all around the network, but there are numerous challenges to this approach, as these hardware probes are very expensive and they are complex to manage and of course difficult to deploy in such a large scale. And in addition, these classical hardware probes, they are often tailored to just one specific service. So what if we could use software-based test agents with multi-service capabilities instead? This would really address a lot of these pains. And as a consequence of these expensive probes, service providers are pretty much inclined to use counters and statistics available in the network devices rather than deploying a lot of probes. But this just leads to yet another pain, namely the difficulty to map or translate device-centric metrics into true end-user experience. Although these counters and statistics are available practically at every single point of presence throughout the network, they normally lack real-time resolution and they have been proven to correlate very poorly with the service as the user consumes. So what if we could measure the service KPIs directly rather than indirectly? Measure it on the wire like the customer. This would really eliminate this pain. And finally, there is a great divide between the fulfillment and assurance workflows that causes a lot of pain. The fulfillment teams are responsible for configuring new deliveries and changing existing ones. And at best, I would say, fulfillment teams perform activation tests using handheld devices, but more commonly, they use just simple pings to verify connectivity. And this is very different and very far from comprehensive activation testing. And in addition, services and circuits are usually verified one by one rather than combined as they are in the real world. And then we have the assurance teams. They typically passively poll statistics for performance management, which results in inadequate insight. And in addition, this assurance is often added as an afterthought, completely separated from the configuration phase, without knowledge of what was actually delivered once, and without adaptability if something changes in the service definitions. So what if fulfillment and assurance could share the same underlying service description and the same requirements for activation, testing, and monitoring? This would clearly eliminate all these pains. So the goal of this PoC is to address all these three major pain points by using one single solution that incorporates both orchestrated fulfillment as well as orchestrated assurance. So the orchestrator will use a common model to first deploy the service and then instantiate and configure the required measurement and monitoring solution. And here, the key is to use active testing and monitoring of the end user services. So let's have a look on how to reach this goal. The approach is based on two parts. First, the model-driven orchestration combined with the virtual test agents, the VTAs. So the orchestrator will configure the service and also instantiate these VNF-based test agents as part of the service provisioning. And these VTAs are currently being defined in the ETSI NFV working groups. And here's a diagram, here's a diagram of the proposed extension of the ETSI NFV reference architecture, where you see the test controller as it manages both the VTAs, the test agents, as well as something called TRAM, the Test Results Analysis Module. In this PoC, Cisco NSO, the Network Service Orchestrator, takes two roles. It acts both as the OSS as well as the NFVO. Cisco also brings their virtualized CSR router as well as the ESC, the Elastic Services Controller, as the VNF manager. And from Netrounds, we bring the virtual test agents and their test controller, whereas Telco Systems brings their Cloud Metro node running on top of Intel hardware. And OpenStack is used as the VIM. And this PoC relates to NFV in two ways. NFV makes it possible to easily bring software-based test agents out in the network. And these test agents can easily be deployed and undeployed at the speed of software, and actually the same speed that the services are being deployed. And by reusing this existing NFV infrastructure that is now being rolled out, this new type of test and assurance capabilities can easily and cost-effectively be distributed over large geographies. And this was really unthinkable of with classical solutions. So this is something really unique with NFV. And in addition, in the right-hand side here, NFV calls for new approaches, like the ones that we now propose in this PoC, since classical solutions, they were not built for this rapid rate of change that NFV will enable. And also, many times, traditional physical assurance solutions, they cannot even connect into this new virtual world. So let's proceed with the use case and the underlying topology. So from a high-level view, this PoC is based around HTTP streaming video over a layer 3 VPN network. And we are assuming that there will be 3 locations where the NFV compute areas will be available to host these test agents and the virtual routers. First of all, at the main data center location, and then secondly on the ingress to the radio access network, and then finally at the edge of the RAN, of the radio access network, close to the black hole demarcation point. At all these 3 locations, we will spin up VNF-based PE routers and test agents. So if we have a look from an end-to-end service point of view, we have the video content servers attached to a P and PE router, further out to the CE router, and finally to an edge aggregation device that typically aggregates multiple eNode Bs. And the dashed line here, they will be configured by the OSS, and the orange box containing the VPE will be instantiated by the NFVO. The circuit, the solid line here through the RAN, is assumed to be pre-configured. This is something that will not be configured by the OSS. And from a MANO point of view, the MANO will see two independent network services, NS1 and NS2, and notice also how the Cisco NSO takes the role of both the OSS and the MANO NFVO. And as you also notice, for instance, network service 2 contains only one single Netrounds VTA in this proof of concept, and in this PoC, the VTA is assumed to be running on top of Telco Systems' Cloud Metro device. And finally, if we have a look at the data plane view, here we see how HTTP video will be requested by the VTAs at various locations. And this allows for active measurement and assurance of the video quality. And in addition, the VTAs will generate active synthetic traffic between each other to perform, for instance, service activation tests like RFC 6349 to perform stateful TCP tests. And notice also that there is a physical test agent in the upper left part that shows that we are also able to do tests outside of the NFV-enabled world. So with this said, I would like to thank you for the attention, and I'm handing over to Stefan, who will show you how this works in reality through his demo. So take it away, Stefan.
Thank you, Mats, for that introduction. We will now move over to a section where we explain how this works and show the live demonstration. I will introduce the basic principles first, then the live demo will show end-to-end service orchestration, including the subset of mono orchestration and binding the orchestration of the assurance functions to the overall orchestration picture. How does that work? Let's look at the left part first. We have a Yang data model. We are modeling the services in Yang. You do that once, you can easily change the data models that will affect the behavior of the orchestrator. But this is the design time activity. Classical orchestration involves a service model for the configuration of the service, and then lately modeling the mono network service descriptors and VNF descriptors for the virtual functions. So these two pieces are what is captured sort of in classical orchestrator functions. What we're adding to the Yang data model are three things. We are adding actions to do things like activation tests. These two things describes the configuration of the service. Is the service working? We have actions here to test it in the Yang data model. The Yang data model also captures SLA definitions, read-write definitions of SLAs, which means that you can't instantiate the service without providing configured SLA thresholds. The Yang data model also captures KPI values that are of course read-only. So for a service, what are the most relevant KPIs which we need to measure? So going back to Mats' presentation, we are capturing the service related KPIs in the Yang data model here. These three things need to be part of a solid Yang data model for the orchestrator to do orchestrated assurance. At runtime, how does it work? At runtime, the orchestrator creates a number of service instances based on the single Yang data model. So again, number one, according to the service config, drive the device config. According to the descriptors, drive the mono orchestration. And not just mono orchestration, because we have an end-to-end service here for a specific customer. So after the network service is spun up according to mono, we need to add end-to-end service-specific parameters to the VNFs as well. Moving over to the assurance functions. In step 2 and 3, we are also instantiating and configuring virtual test agents. Since the orchestrator knows the endpoints, the orchestrator can drop virtual network functions to do testing, can configure those agents to do proper testing according to the service. Once that is done, for the specific service instance, we do an activation test from the orchestrator, and we turn on monitoring for that specific service instance. So these two things are the major things of orchestrated assurance. Note well also that starting virtual network functions to do testing and assurance is part of the lifecycle. And this is constantly running because we might modify the service, we might modify the SLA and cost parameters, which needs to change this. we might remove and add legs to the VPN. That requires removing probes, adding probes to the correct legs. We might delete the complete service instance for a customer. The orchestrator then need to undeploy all the virtual test functions in the network, need to tell the assurance system to stop monitoring that specific service instance. So constant change here. The data model for the demo I will show looks like this. An end-to-end Yang data model for the complete VPN, which has endpoints. The endpoints have read-only KPI values. The endpoint also has actions related to assurance. The endpoint might be a physical endpoint or it might be a virtual. In case of virtual, it refers to a mono network service descriptor, which constitutes of virtual network functions, for example, a virtual PE router or a virtual test agent. The endpoint also has two different video SLAs and a network SLA. So all of this is captured in one single data model that we will utilize in the demo. The demo flow is basically like this. It's not, the details might differ, but this is sort of a best way to describe it. First step, NSO, the orchestrator, acts in the OSS role, doing the physical configuration on the physical devices. Step 1 here in the circle. Number 2 is acting in the NFVO role, instantiating the mono network service. So we have one mono network service here, which is booting a virtual PE router, attaching a virtual test agent there, attaching a virtual test agent there. A second mono network service is a virtual test agent on the compute space available on the edge node out there. So note well, two mono network services, that those guys are a subset of the complete overall end-to-end service. Finally, the orchestrator will do the last steps. It will send active traffic to make sure that the end-to-end service is working. Once that is done, the orchestrator will turn on SLA monitoring, KPI monitoring. Since we have the Netrounds test controller here, we have the virtual test agents here, the orchestrator can tell the test controller, these are the SLAs, these are the KPIs, please monitoring that ongoing. Over to the live demo. Since this demonstration is focusing on orchestrated assurance, I have already started the demo with provisioning the VPN. So we provisioned a VPN to the physical endpoint here and back to the video server distribution. As part of that, NSO did start a virtual PE router, connected a virtual test agent to that, a virtual test agent to the CE, and booted the virtual test agent at the demarcation point to the telco systems device as well. So all this happened, so going back to the topology diagram, what NSO did, acting in both NFVO role and OSS role, the end-to-end service configuration, instantiating the two mono network services. One mono network service is the VP, the two VTAs, and the other one is this one. So we will not go into details around the network service descriptors and VNF descriptors, but all that is in place to drive this thing here. So where we are now, if we go back to the service lifecycle, we've done the device configuration, we have done the mono instantiation, and also we have done the service-specific VNF configuration. We are now going to move over to the last two steps, the activation testing step and the ongoing monitoring. So what you can do here is to start the activation test. In a real scenario, the orchestrator would do this automatically, but here I do it manually for demonstration purposes. So the virtual test agents will now drive heavy-duty traffic to validate that the service is okay, the traffic is flowing, that we're meeting the KPIs. And of course, we don't have customers here because an activation test should really challenge the service and see that everything is running fine. This takes a while, so we can move over to the dashboard to see how far the activation test has come. So it starts by committed information rate validation. Once that is done, moves over to stateful TCP testing. So these are the two steps. A real test normally contains even more than this, but we include these two ones in this demonstration to keep it fairly short. You can build activation tests by dragging and dropping the test steps in the UI here. We can see what's going on, and this step takes about 30 seconds. Okay, so here we can see that the committed information rate validation succeeded, the RC6349 tests succeeded, so this is a proof that the service is okay, the customer will be happy. You can automatically send a link, or you can automatically send a PDF report. So in this case we have a PDF report documenting the complete test scenario. It shows all the networking KPIs, loss, delay, jitter measurements. It shows all the timestamps, all the measurement steps that were performed. So that was the activation test, an integral part of any service orchestration scenario. Let's now move over to the constant monitoring step. Going back to NSO here, of course again this is done by the orchestrator automatically, but here I'm demonstrating. So here we can start the UDP monitoring, and we can start the video monitoring. So remember, going back to the Yang data model, we have defined SLAs. So for example here we picked a UDP SLA and the video SLA. Those are defined in the Yang data model, and the values are given as input. So now the NSO makes sure that the assurance system is constantly monitoring these SLAs, and we have an SLA indication up here, and it's still red because we just started. As you see, we have not yet started to receive any KPI values. So in a couple of seconds we will start to see values coming in here, and we will see the SLA values. We can move over to a dashboard view. So here we have the test for the two SLAs. We have the basic video monitoring test, which just started. Everything looks green so far. And we can see the configuration parameters of that SLA. We can move back. We can also check video over the top SLA. Still getting up and running. And here we see the configuration of that test. So it drives video traffic from that URL and measures buffers, etc. So we just started here, and now we can see it's starting to get in green. And if we leave this on for a couple of minutes, we'll see even more and more coming here. Going back to the dashboard, in the NSO web UI, we can see the status. We can see that UDP is perfect, it's 100%. We can see that the video is still violated, it's moving up, it's 32%. In a couple of minutes it will get good. And again, we see all the real-time values live here in the NSO web UI, directly driven from the Netrounds test controller. Here we have an example where the monitoring has been running for a while. We see that we have 2 violations here. And what's important is that you can drill down by clicking here, drill down into the individual values. You can turn on which KPIs you would like to see, and you can zoom in to this area where we had a violation there. We have this value going up, so we can drill down into any detail to analyze what actually went wrong and why the customer is a bit upset. So this shows a tight integration between the orchestration process and an active service testing and an SLA aggregation engine, and put everything together from an orchestration perspective. What I didn't show here in this recording is details around the mono descriptors, details around the deployment of the virtual probes, etc. Just due to short time here, if you send an email to us or came by our booth in the Lay 123 Dusseldorf conference, we can go in any depth of detail in the running code. So let's go to a summary of what we have presented and demonstrated here. There are 3 things we're going to focus on. The first one is an integrated view on orchestration being not just fulfillment but equally important assurance, so that with a model-driven approach we can have an agile delivery of the services, flexible, you can modify the data models to adhere to SLA definitions, etc. And while the orchestrator drives the configuration of the service, it also drives the assurance systems to make sure that we have an assured service. When it comes to service assurance, note well we're talking about service assurance. Fundamental principle we're focusing on here is that you need to measure service KPIs directly. It's very hard to indirectly infer them from device counters, lookups in the inventory systems. We have been trying that in the industry for decades, and we have to admit it really doesn't show the service KPIs. So direct measurements of service KPIs is important. We also focus on a common Yang data model covering both fulfillment and assurance aspects, as well as the end-to-end service and the subset of the mono orchestration principles. All of this has been implemented and shown in this demonstration. And if you have any deep dive questions, as I said, there's a lot of things we didn't show here, so ping me or Mats with questions. Things we didn't go into detail here is around the service KPIs, the service tests. We didn't go much into details in the Yang modeling, in the descriptors, etc. So just feel free to ping us, we can go in any depth. So again, thank you for listening. Bye.